Okay, so picture this. Something massive, incredibly fast, and totally mysterious is hurtling through our solar system right now. It's only the third interstellar visitor we've ever confirmed, and let me tell you, it's raising some pretty fascinating questions. So let's dive in and meet the object at the heart of this whole cosmic puzzle. Its official name is 3I/Atlas, and it's already kind of rewriting the rules for what we thought could wander into our neck of the woods. And right off the bat, we've got a huge mystery on our hands. I mean, what is this thing? It's behaving so strangely that it doesn't fit neatly into any box. Is it just a really, really weird comet? Or are we looking at something, well, something completely new? To give you an idea of just how wild its journey is, it's blazing along at an incredible 60 kilometers per second. That speed? It's a dead giveaway. It tells us this object is not from around here. It's on what's called a hyperbolic orbit, which basically means it's just passing through. A tourist in our solar system, not a resident. And this is where the scale of this thing just gets mind-bending. The actual solid part, the nucleus, is probably somewhere between 1 and 50 kilometers across. But its coma, that fuzzy cloud of gas and dust around it, is a staggering 700,000 kilometers wide. To put that in perspective for you, that is about half the diameter of our sun. Yeah, this thing is an absolute cosmic oddball. So where is this massive visitor headed? Well, its flight path is taking it straight through one of the busiest, most crowded highways in our solar system, the main asteroid belt. And this is what makes its path so unique. You see, a lot of comets come in at these really steep angles, flying way above or way below the flat plane where all the planets hang out. But not 3I/Atlas. Nope, it's flying almost perfectly flat, cutting right through the densest, most crowded part of the asteroid belt. Now, to be fair, space is big. I mean, really big. The odds of a little man-made probe like Voyager actually hitting anything as it passes through the asteroid belt, they're about 1 in a billion. So, the chances are pretty low. But here's the kicker. 3I/Atlas isn't some tiny probe. It is a massive object with its own gravity, its own electromagnetic field. So while the probability of it hitting something is still super, super low, the truth is, nobody has actually run the numbers on a supercomputer for an object of this size with these properties. It's a complete unknown. So if you want to follow along, get your calendar out for 2025. On October 3rd, it'll make its closest pass to Mars. Then, around October 21st, it's going to swing around to the far side of the sun from us, which means it'll be really hard to see. And finally, on October 29th, it reaches perihelion. That's its closest point to the sun before it heads back out into deep space. Okay, to really wrap our heads around what's happening as this thing barrels through the asteroid belt, we need to talk about the seriously weird physics of space dust. You see, 3I/Atlas isn't just flying through a void. It's moving through something called a complex dusty plasma. It's this bizarre soup of charged gas and charged dust, and the way it all interacts is so complicated that, honestly, even our top plasma physicists don't have it all figured out yet.
So how does dust just float around an asteroid in space? Well, think about rubbing a balloon on your hair and how your hair stands up. It's kind of the same idea, but on a cosmic scale. Solar radiation zaps the asteroid's surface, giving it a charge. This creates a little electric field that lifts up charged dust particles and just holds them there, levitating in a layer.
And it turns out an object's size and gravity play a huge role in this. A smaller body with weaker gravity, like the asteroid Eros, can actually hold on to bigger dust grains, about 2 millimeters in size. But something much bigger, with way stronger gravity, like our moon, can only levitate tiny, tiny particles. It's this delicate cosmic dance between gravity and electricity. So we've got this strange object on a strange path with some strange physics going on around it, which, of course, brings us back to that one huge question. What in the world is 3I/Atlas? Well, there are a few leading ideas floating around. The most likely answer is that it's just a very, very unique type of interstellar comet. It's also possible it's one of our own, an object from the Oort cloud that got knocked onto a really weird path. And of course, because it's so strange, some have even speculated about it being technology. We're just laying out the possibilities here that the sources discuss. And the reason for all this speculation is that this thing just doesn't play by the rules. For starters, that gigantic Coma formed way farther out from the sun than we'd expect. And its tail? It took way longer to develop than a typical comet's. These little quirks are exactly why scientists are so fascinated by it. But here's the thing. No matter what 3I Atlas turns out to be, comet, rock, or something else entirely, its journey through our solar system is a pretty powerful wake-up call.
And this quote really just hits the nail on the head. We have the technology now with supercomputers to model and simulate these kinds of events. And the flyby of 3I Atlas is a stark reminder that we probably should be using that amazing capability to understand what's really going on out there.
So here's the bottom line. It's extremely unlikely, but there is a non-zero chance that an object like this could smack into an asteroid and send it on a completely new path. It's a reminder that our solar system is a dynamic place, and we really need to keep our eyes on the sky. Ultimately, 3I/Atlas is like a fire alarm for astronomy. It forces us to remember that our solar system isn't some static, peaceful place. It's an active, chaotic shooting gallery. And it leaves you with a really chilling question, doesn't it? What other cosmic visitors are out there, right now, heading our way totally undetected?
Welcome to the debate. Today, we are focusing on the transit of 3I Atlas, the third observed interstellar object currently blazing through our inner solar system. This visitor is moving at an extreme velocity, around 60 kilometers per second, on what astronomers call a hyperbolic orbit, meaning it's not gravitationally bound to the sun and will eventually leave our system forever.
Indeed. And it's an unprecedented event, not just because of its origin, but because of its truly bizarre characteristics, including a massive carbon dioxide-rich coma. The material we are analyzing raises two distinct non-zero risks associated with 3I Atlas's passage, particularly given its alarming trajectory.
That trajectory is key. It's on a 175-degree retrograde orbit, meaning it is traveling in almost the exact opposite direction to the vast majority of objects in our solar system. It's cutting right through the main asteroid belt, and that brings us to our central question. Which risk assessment should immediately prioritize our scientific focus? Is it the urgent physical threat of orbital deviation and collision, or the less understood indirect electromagnetic threat posed by its complex, dusty plasma coma? I argue that we must prioritize the physical orbital risk, focusing on calculations that can resolve a catastrophic, though, low probability threat.
I have to push back on that premise immediately. I believe the scientific focus must prioritize the electromagnetic threat. The dynamics involved there are far less predictable than Newtonian mechanics, and the potential for widespread systemic infrastructure disruption from space weather poses a more complex and dynamic challenge, a challenge we are fundamentally unprepared to handle. That uncertainty, that demands our immediate scientific attention.
My core argument rests on the potential magnitude of the consequence and the immediate solvable scientific failure pointed out in the source material. The primary and most consequential risk lies in the possibility of physical redirection or collision. We're not talking about a small asteroid. The upper estimate for the nucleus diameter of 3I Atlas is a colossal 50 kilometers, making it significantly larger than, nearly every object we encounter in the asteroid belt.
Right.
Its trajectory, as you mentioned, is horrifying. That 175-degree retrograde orbit is only 5 degrees off the ecliptic plane. To visualize this, it is literally crossing traffic at light speed, traveling opposite to the flow. As the material states, it is cutting right through the meat in the body of the asteroid belt.
That movement is certainly alarming, I agree. But let's consider the nature of the risk. Even with a 50-kilometer object, the baseline collision chance is cited as extremely low, around 1 in a billion. So why commit maximum resources to a remote, albeit catastrophic, physical event when a more pervasive, dynamic threat is already unfolding?
The urgency stems not just from the potential outcome, but from an immediate scientific omission. While the collision chance is low, the material notes those odds are probably a little bit higher because the object is so massive that we can no longer treat it as a point mass in our calculations. Its size means its own gravitational and electromagnetic forces require complex, high-precision and body calculations. when considering its near passes with known asteroids. Crucially, the source strongly criticizes the lack of an official calculation on all the objects that we know of in the main asteroid belt and 3 atlas. This suggests a negligence in addressing a catastrophic physical risk that is computationally solvable with our existing supercomputer infrastructure. We must first address what we can calculate.
I have to admit, the negligence regarding calculation is a strong point. It really is. However, when we look at the unique characteristics of 3I Atlas, the most complex and dynamic threat is not its physical path, but the bizarre plasma environment it is actively creating. The core argument for prioritization, for me, must be the complex, indirect, systemic interactions this object facilitates across the heliosphere.
Okay.
The evidence for this is truly staggering. 3I Atlas is surrounded by an unusually large coma, a complex cloud of dusty plasma composed of CO₂-rich gas and dust that spans approximately 700,000 kilometers across. To put that in perspective, that cloud is roughly half the diameter of the Sun. This is completely anomalous for a transient object.
It is unusually large, absolutely. I see that. But what exactly is dusty plasma, and why should it trigger a systemic concern?
Well, dusty plasma is essentially a normal plasma, so ionized gas, but infused with micro and submicron-sized solid particles, the comet dust. These particles are not neutral. They rapidly take on a significant electric charge, whether positive or negative, within the solar wind. This charged, dusty plasma is now directly interacting with the heliosphere's vast electromagnetic system. This is where the risk becomes systemic, because complexity in space weather modeling increases exponentially the moment these charged dust grains are introduced into the plasma equation. The mechanism is indirect, yes, but potentially powerful. We know our solar system contains an inwardly flowing radial electric current, running from the outer reaches toward the Sun. These newly charged dust grains can flow down that existing current, acting as conduits or maybe amplifiers. If this charged material hits Earth's magnetosphere, it could significantly strengthen the interplanetary magnetic field, or IMF, potentially triggering enhanced and unpredictable geomagnetic activity, especially if it coincides with a moderate solar event. This level of uncertainty in the potential for infrastructure disruption, power grids, satellites, communications, make the plasma dynamics the more significant threat deserving immediate scientific focus, in my view.
I appreciate that breakdown of the mechanism, but let's return to the likelihood calculation. The chance of a catastrophic physical impact leading to redirection toward Earth is remote, yes? But it's an unquantified remote risk, as you noted yourself. If that low probability event occurs, the consequences are, well, it's existential. The consequences of enhanced geomagnetic activity, while systemic, are generally manageable disruptions, aren't they?
I have to push back on the framing that the systemic risk is merely manageable. That perspective relies too heavily on past events, perhaps. I would argue that given the object is already pumping charged dust into the interplanetary medium, a large-scale geomagnetic event is a more probable broad disruption than a physical redirection. More importantly, while the physical event is low probability, high consequence, the electromagnetic event feels more like high probability systemic consequence. We know space weather is a constant threat. This object is acting as an accelerator for that vulnerability.
Yet the urgency regarding physical calculation stems from the fact that the object's sheer size changes the underlying physics. The material suggests that the 1 in a billion baseline collision odds are a lot bigger for 3I Atlas, not just because it's massive, but because n-body interactions become far more complex. When an object is 50 kilometers across, its own tidal forces and electromagnetic interactions with nearby asteroids are no longer negligible. This is a complex physics problem that we know how to solve mathematically, but have failed to execute due to procedural neglect. The physical threat is tangible, calculable, and therefore its neglect is the immediate scientific priority.
Your point about computational negligence is well taken. It really is. But that still focuses on avoiding one specific catastrophic endpoint. My concern is the fundamental dynamic change this object is inflicting on the medium of space itself, you know?
I'm not convinced that this change is solar system-wide, though. I worry that we are assuming a massive systemic impact from what is essentially a single, albeit large, comet's off-gassing. Are these plasma effects not localized, similar to the phenomenon of dust levitation seen on smaller asteroids like Eros, or even the Moon, where dust layers form in equilibrium based on gravity and electrostatic charge? Why assume a massive systemic impact on the interplanetary magnetic field?
That premise worries me because it conflates localized electrostatic levitation with injection into the solar system's largest electrical structure. This is not about localized dust equilibrium. This is about 3I Atlas injecting a massive volume of charged particulate matter directly into the interplanetary medium. As I mentioned, the solar system hosts a large, inwardly flowing radial electric current.
Right, the current.
Exactly. This current is the backbone of the heliosphere's electromagnetic environment. When 3I Atlas's enormous charged coma interacts, these dust grains serve as mobile charges flowing down that current, providing a direct, system-wide transport pathway. This mechanism is powerful enough to potentially strengthen or alter the shape of the interplanetary magnetic field, the IMF. If the IMF is strengthened or perturbed, the resulting geomagnetic activity can induce currents in Earth's power grids, cause significant satellite drag, or even temporarily blind sensitive orbital communication systems. This effect is far beyond localized levitation. It's a dynamic change to the physical environment we operate within.
Okay.
Know from the source material that comets like Pan-STARRS 2013 and Shoot-Chin-Shan 2024 have been strongly linked to instances of intense solar activity and corresponding space weather events. This is compelling evidence that cometary plasma interactions are highly dynamic and can directly influence the Earth environment. This strongly argues for prioritizing the study of 3I Atlas's bizarre, growing coma and its tail evolution now, because that is the origin of the dynamic space weather risk.
That's a compelling argument based on historical association, I admit. But have you considered that relying on past comet associations for prediction is fundamentally less sound than focusing on its known fixed orbital mechanics? 3I Atlas is explicitly defying normal cometary behavior. It is only now beginning to form a tail, and its 700,000-kilometer coma is much bigger than normal comets. Furthermore, the composition is highly unusual, CO₂-rich rather than the typical water ice.
True. It is unusual.
Right? So if it defies classification and behavior, relying on the statistical association of other comets with space weather may be misleading. Its unique nature, particularly its unusual off-gassing composition and size, makes its orbital path through the most populated part of the inner solar system the more reliable and pressing concern, because we can at least use fixed mechanics to predict that risk. Plasma interactions here may be entirely novel, making immediate predictive defense based on past analogs difficult, perhaps impossible right now.
I'm sorry, but I just don't buy that it's simply a novel problem to be put on the back burner. That level of novelty represents a profound knowledge gap in our understanding of the heliosphere. While physical calculation is necessary, the dynamic and complex plasma physics involved represent a fundamental scientific frontier that 3I Atlas forces us to confront. Because we know complexity gets really crazy, as the material says, when dust is introduced, focusing resources on understanding how 3I Atlas's dusty plasma contributes to enhanced geomagnetic activity is the priority for developing systemic defense against space weather, a threat that is constantly occurring and poses a permanent vulnerability, unlike the one-off physical impact risk. We must prioritize fundamental understanding of the medium we live in.
If this object is a wake-up call, as the source material suggests, the most actionable and immediate response mentioned is the use of supercomputers to model the trajectory and collision risks of known objects. We have the technology to address the 50-kilometer object passing through the most populated region of space. The low probability risk of physical redirection cannot be ethically ignored if the computational capacity to calculate it and potentially mitigate it exists right now. That is the immediate scientific priority. We have to address the predictable catastrophe before diving headfirst into the unpredictable systemic effects. To summarize my position, The sheer size of 3I Atlas, combined with its alarming path directly through the asteroid belt, the meat in the body, necessitates the immediate, rigorous calculation of trajectories against known objects. Mitigating the non-zero chance of catastrophic orbital deviation, leveraging our existing computational ability, represents the most urgent scientific imperative raised by the material.
And my summary remains focused on the knowledge gap and the pervasiveness of the risk. 3I Atlas's enormous, charged coma introduces poorly understood complex dusty plasma dynamics into the inner solar system, creating the potential for enhanced geomagnetic activity on Earth. This is a less direct but potentially more dynamic and unpredictable threat that serves as a profound wake-up call regarding the fundamental deficiencies in our ability to model and defend against space weather. Prioritizing the bizarre plasma behavior is prioritizing systemic defense.
Both perspectives underscore just how uniquely important the transit of 3I Atlas is. It is dynamically changing our inner solar system environment and providing a rare opportunity to study both known physical dynamics and highly complex indirect interactions.
Indeed. Whether we prioritize resolving the calculable physical risks or unlocking the unpredictable electromagnetic dynamics, there is clearly much more to explore in the material regarding this bizarre interstellar object and its ongoing, unprecedented influence on our solar system environment.